Hi and welcome back. So in the past video we were working through this problem using dimensional analysis where I said that my cousin Allison went out running and she ran at 6.5 miles per hour for 45 minutes and we were trying to figure out how many meters would she have gone. And we did it using dimensional analysis, and in the last video we said that we were going to start with information we knew and then eventually we were going to, at the end of the problem, convert that to meters. And I told you at the beginning of the video that I've had professors tell me that, this is the best way to do it and, stuff like that, that you should start with something you know and then finish up with what you were looking for. So we finished with meters. And I've also had professors essentially say that you should start with I guess, what it is you're looking for. That what it is you're looking for should be the first thing that you write down on the paper, and then you should throw in all of this other information. You should throw in, after you know exactly what you're looking for, you should figure out how to put in all the other information that you've been given into the problem to get the final answer that you're looking for. So what we're going to do in this example is we're going to do another similar Algebra 1-ish example using dimensional analysis, except we're going to start with what it is we're looking for. And it's going to be a little bit weird, kind of a weirder problem, but hopefully it'll still be useful. So what we are going to say is we're building a new sports arena. It's going to be able to hold 100,000 people, so 100,000 people. And what we want to know, and I think that's about a standard size for a sports arena, but anyway, I guess it doesn't really matter. I'm just completely making all this up on the fly. But we build a new sports arena. It holds 100,000 people, and what we want to know is how many tons of concrete we need to buy in order to build the parking structures, in order to build all of the parking garages and everything. And so you can imagine that there's a lot of other information that we need to know in order to get to this point of saying, okay, we started out, we're going to have 100,000 people. We need to figure out how many tons of concrete we're going to need to build our parking structures. And you can hopefully imagine the problem, and maybe I should draw a picture and say, like, okay, well, here's our stadium. I don't know, maybe there's a basketball court inside the stadium. I'm not that great at drawing it, but then we've got all these bleachers over on all these different sides. There are our bleachers. This is there. So we've got lots of stands over here, and we are going to have 100,000 people that could be here watching, let's say, our basketball game. And then over here we've got our parking garages somewhere. So we've got all of our cars are parked in these garages. And we want to know how many tons of concrete we are going to need in order to be able to build enough parking garages to fit the cars that brought all of these people. So we're going to start off, and in this example, we're going to start with what we know, not with what we know. We're going to start with what we want to get, which is tons of concrete. So we're going to start with that. That's what we want to get. We're going to say that is going to be equal to, let's say, for every parking structure we build, let's say we need, I don't know, let's say we need 500 tons. Now I'm completely making this up. 500 tons of concrete for one parking structure. So now we know we've figured out that we know we need 500 tons of concrete for one parking structure. And so now we need to know how many cars does each parking structure hold? Well, each parking structure, let's say that each parking structure holds I don't know, let's say for every one parking structure, I'm just going to say PS, for every one parking structure or parking garage, let's say it holds 1,000 cars. Okay? Next, and maybe I should have given you all of this information beforehand, but hopefully you can still get the gist of what I'm doing, even though I'm really just making this up on the fly. So now so now we need to know how many people come per car to this game. And let's say well, let's just say everyone's the same. Let's say that every one car is going to carry, let's say every one car is going to carry, let's say 3 people. 3 people. And then finally, we can say how many people are we going to have. We're going to multiply this times, well, we need enough. The maximum that we could ever possibly have at our game is 100,000 people. So we are going to multiply this times 100,000 people. So now you can see that all of our units are going to cancel out, and we started with what we wanted to get, and you can see that this is definitely not a perfect problem because we're going to have fractions of parking structures built and everything, but this is, it's just an Algebra 1 type of problem that I wanted to show you, where essentially we started with what it was we wanted to get. We were looking for how many tons of concrete that we would need based on building an arena with 100,000 people. So let's let's go ahead and work this. Let's just get out the calculator, do this real quick. So we are just going to, and we can multiply this, if we were starting with what we knew, we would start with multiplying our 100,000 people. But it doesn't matter, right? We can multiply or divide from either direction. We have the communicative property of multiplication and division. So now we're going to say that 500, and we don't have to multiply or divide by 1. So we can just say 500 divide by 1,000 divide by 3 times 100,000. That's 100,000. So that means that we are going to need 16,600. And how many significant figures? Well, you could say we even only have, let's say that we only have, let's say we have 2 significant figures in this calculation. So we are going to need 17,000 tons. So what we come up with is that we are going to need, let's say, 17,000 tons of concrete. So that's our answer. Hopefully, this probably wasn't the best example, the best example, but hopefully you can see that I'm solving a very simple problem, and all I'm using is dimensional analysis. All I'm using are these conversion factors where I'm just multiplying by 1 each time. And, we'll definitely do more problems in the future, and probably the next example, these have all been sort of algebra type problems. And the next example, I'll actually do an example of something that actually looks like chemistry, where we're actually figuring out a problem that looks actually like chemistry just by using dimensional analysis. But the important thing to realize is that all we're doing is we're multiplying by 1, essentially, at each stage, and that all of our units, parking structures cancel with parking structures, cars cancel with cars, people cancel with people. So all of our units are going to cancel out, even though these are kind of, strange units. All of our units cancel out, and then we end up with the unit that we're looking for, which in this example was tons of concrete. So anyway, hopefully you found this useful. Again, in the next video, I'm going to actually do an example that actually looks something like chemistry. So anyway, thanks for watching, and I'll see you in the next video.